Okay, so as we just were discussing this problem, um, what we are going to do is we are going to find the new values of um, the pressure angle and the diameters of the pitch circles. ठीक है जी? Again, we know that the velocity ratio that is देखें velocity ratio जो है since we said, if you remember, we said that omega 1 r1 is equal to what? Omega 2 r2. ठीक है जी? Ignore the sign. So we are taking the absolute values of these. ठीक है जी? We're taking the absolute values. ठीक है जी? Now, can I write that omega 1 over omega 2, what will that be equal to? Omega 1 over omega 2 will be equal to R2 over R1. Can I say that since R2 over R1, that is 2 times, अगर इसको मैं 2 से multiply करूं और इसको भी 2 से multiply करूं, nothing will happen, right? But this will become D2 over D1, right? So basically this is my dp over well, okay, so d2 over d1. I'll further go over this. Achha, do I know that p is equal to n by d, right? So d is equal to what? N by p, right? So instead of d1 by d2, I'll write n over n2 over p divided by n1 over p, right? So since p and p are the same, therefore my d2 over d1 is equal to n2 over n1, right? So this means that if I take the number of teeth, देखिए, my dp dash over dg dash is equal to the number of teeth on the pinion and the number of teeth on the gear. ठीक है जी? तो ये मेरे पास इस तरह से I can write that कि d1 by dp by dg is equal to इसका reciprocal अगर आप ले लेना, ठीक है जी? तो that is 16 by 40. ठीक है जी? तो I can go ahead and put the ये I have two equations, equation 1 and equation 2. I can take these two equations and find the value of dp dash and dg dash from here. I can also find out phi dash, which will be cos inverse of rb pinion divided by dp dash over 2. ये basically r वही equation हमने इस्तेमाल की है कि rb is equal to r cos of phi. Do you have any question here? Any question? Acha ji. Now, we were discussing the angle of approach and the angle of recess. ठीक है जी? Now, what is the angle of approach को अगर हम QA से denote करें, and if we denote the angle of recess by QR, so the total angle of action is QT, right? Now, what is contact ratio? Physically it means that how many um, teeth are meshing with each other at an instant. ठीक है जी? So basically we denote that by MC, and MC is equal to QT over P. Now what is QT? QT is the total sorry, we will not call this the angle. Rather, if we take this in arcs, then this is the arc of action, sorry, the arc of approach and the arc of recess, and the QT will be the total arc of action. ठीक है जी? तो basically अगर हम MC, which is the contact ratio, if we calculate that, that is going to be QT over P. Now, what is QT over P? Basically, देखें, the angle, the arc of approach will be from here to here. ठीक है जी, this is the arc of approach because it's going to go to the center, and the arc of recess from here, and P is the circular pitch. Now, what is this pitch? This is the sum of the tooth thickness and the width of gap, the width of space between the two teeth. So, if this is equal to 1, that means that only one gear is in contact with each other. Now, for a spur gear to have a contact ratio, that should be at least 1.2, right? So that you make sure that when one gear is disengaging, another one is partially engaged. ठीक है जी? So at least 1.2 should be the angle of the contact ratio, and we can also express this in this ratio from the length of the line of action, which will be LAB. If I take, you know, LAB, which is the line of action, the length of the line of action, LAB, divided by P cos of phi, that will give me the length of yeah, it will give me the ratio. Yeah, this equation 13-9 will give me the ratio of the arc of action to the length of the or the circular pitch. ठीक है जी? तो arc of action over the circular pitch. ठीक है जी? Now, again, what happens in gears? Let's say if these teeth mesh with each other smoothly, it is fine. But what happens? Let's say if this gear, which is rotating in this direction, this one will rotate in the and this, if it is rotating in this direction, uh, let's say, what will happen? देखिए, sorry, for now let's consider that this gear is rotating in this direction. ठीक है जी? If it is rotating in this direction, it is going to come in contact with this gear tooth, and it is going to push this in this direction. Therefore, this one is going to rotate in this direction. ठीक है जी? Now, let's say at the end, यहाँ पे अगर इस tip को मैं देखूं तो this tip is involute, right? But over here, some portion of the tooth, which is this one, this is not involute. This is not involute. Only the portion that is above the base circle, that is involute, right? So what will happen if this involute portion, let's say if I extend this involute portion, rather let me use some other ink. ठीक है जी? अच्छा जी, let's say if I extend this a little bit, इस tooth को मैं extend करता हूँ ऐसे, तो what's going to happen? देखें, this tooth is digging into this tooth. So the scenario is that if this is the tooth and another tooth comes in and that kind of goes into this tooth, this phenomena is known as interference. ठीक है जी? This is known as interference. Now, what happens over here is that this involute portion of this gear comes in contact with the non-involute portion of this gear. right? So what will happen that it will disturb the constant angular velocity ratio. Basically, this is not rolling over it, it is rather pushing into the tooth over here. So there can be a way, there can be ways where we can get rid of this. For example, one way would be that we actually do not go straight, but rather make the tooth like this, right? So this is known as undercutting, right? So this is known as undercutting. But the more you do undercutting, you are making this tooth weak over here. The tooth is going to break. So therefore, there are ways to to get rid of interference, and the way to get rid of interference is that in spur gears, in order for two gears to mesh with each other, there are defined number of teeth, that at least the number of teeth should be this many if you want interference free meshing. For example, once for spur gear with 1 to 1 gear ratio, the smallest number of teeth which will not have interference, that should be equal to this. ठीक है जी. और k यहाँ पे क्या है? K is basically the for full depth it is 1, and for stub it is 0.8, which is a standard depth. It doesn't go all the way down. So you can calculate the number of teeth over here. Now let's say similarly for spur gear to mesh with a larger gear with gear ratio of ng over np, the number of teeth on the pinion should be this one, and this will be the smallest number of teeth on a pinion. At least it should have this many teeth. Now similarly, the largest gear with specified pinion that is interference free should have these many. You can calculate the number of teeth over here, and the number of teeth for a rack can also be calculated using formula 13-13. In order to have, let's say, for example, we want to to keep some angle, for example, 20 degrees. ठीक है जी. Pressure angle, the most useful values of 13-1 and 13-2 are calculated as shown. देखें the number of teeth, अगर आप 20 degrees angle लेते हैं तो what we will have is the largest gear will have ये हमारे teeth होंगे. If you have 13 teeth on the pinion, ठीक है जी. So your teeth on the maximum teeth on the gear should not be more than 16.45, which is 16 basically. देखिए why? Because you have to make this an integer. You cannot have half tooth or 1/4 of a tooth or 0.75 of a tooth. So you have to round this figure. Since this is maximum, therefore you should not have a max of 16 teeth on the pinion, where the on the gear where the pinion has 13 teeth. And similarly, you can see over here कि आपके जो गियर के टीथ हैं वो कितने होने चाहिए. ठीक है जी. इंक्रीजिंग द प्रेशर एंगल, अगर आप 25 प्रेशर एंगल लेते हैं तो फॉर दैट योर नंबर ऑफ टीथ क्या होंगे कि दे विल decrease. देखें यहाँ पे आप देखें the number of teeth on the pinion is 9, and if you calculate using those formulas for taking the phi equal to 25, that is 13.33 is the maximum. So basically it is 13. ठीक है जी. So remember these values, some of these, and when you are designing, you should remember these values for ready reference. Otherwise you can calculate. ठीक है जी. So eliminate interference. How do we eliminate that? Interference can be eliminated by using more teeth on the pinion However, if the tooth size, that is the diametral pitch, is to be maintained, then an increase in the teeth means an increase in diameter, which is because P is equal to N over D. So you cannot like make a really big gear. Interference can also be eliminated using a larger pressure angle. Why? Because the teeth move away from each other and they are not going to dig into each other. This result in smaller base circle. So smaller, the more of the tooth profile is involute. Now, this is the primary reason for larger pressure angle. कि हम larger pressure angle क्यों इस्तेमाल करते हैं? That is the reason, because we want to move away the base circles from each other. So you will end up with a more of the tooth portion will be involute rather than just a straight line. ठीक है जी? The disadvantage of larger pressure angle is an increase in the radial force and the same amount of transmitted force. ठीक है जी? तो इससे that is the disadvantage of making a larger pressure angle. Forming of gear teeth, I would ask you to look at this. These are different, there are different ways: sand casting, shell molding, investment casting. You can also go ahead and cut teeth by machining, which is milling, shaping, and hobbing. I would say you should probably look at these. There are some pictures over here for how gears are cut. There are standard um, cutting tools, multi tip tools. ठीक है जी? And you can use them. ठीक है जी? अच्छा, I think we should